Okay guys, so let's start the class. Okay, so yesterday we stopped with the relative motion, right? So today is the 100 days challenge for the day 4. So I hope, like, let us revise once what is the relative motion and what is the formulas we need to use it. Okay, and then we'll go for this question. Yesterday we stopped with this question, right? So usually we'll use the formula if S is given, position is given, position of A with respect to B is nothing but SA minus SB. This is the formula you need to keep in mind whenever you are doing the relative anything, position, velocity, acceleration, whatever the things they are asking. So next we will go for this question. Let us see what is that question is given. Like, analyze the question first. I'll like zoom it, I guess. Yes, it's visible now. Fine. Yes guys, so an old man and a boy are walking towards each other. So this is a boy and this is the old person. Okay, they have mentioned boy, tree, bird and old person, each other, and a bird flying over them as shown in the given figure. Okay, so they said about a boy, old person and the bird. The tree is at rest. Okay, velocity of the tree is 0 meter per second. 0 meter per second. This is tree. Okay, now the given question what they have asked, find the velocity of a tree, bird and an old man as seen by the boy with respect to, like, see, this boy is seeing and observing the nature. See, bird is flying, tree is there and old person is coming. I need to find the velocities. Okay, I need to find the velocities. Okay, first thing, I need to find the tree. What is the velocity of tree with respect to that boy? Boy is running like this and tree is standing there only. How much speed will be there? Like, without using the relative velocity concept, we can assume, no. See, a person is at rest and you are running with 16 meter per second. What you will say? I am coming away from the person with 16 meter per second, right? That's what the concept we are going to use in the relative velocity. Okay, so what I can say, the first thing, is it visible, right? Yes, fine. So it is coming in this direction, boy is coming in this direction and tree is going away from him, So what I can say, this velocity of tree with respect to boy, no, that's what, no, is equals to velocity of tree minus velocity of boy, velocity of the boy. So this is the first question, right? Velocity of tree with respect to boy, velocity of tree is 0, boy velocity is 16, so it is minus 16 meter per second. For the first thing, this is minus 16. Minus 16 in the sense like it's in the negative x axis, no? So minus 16 I cap. Next, bird. See, bird is running 20 meter per second. It makes an angle 37 degree with respect to horizontal they have given. So they have mentioned that, like, they have solved for the cos, like x axis as well as y axis. So 12 meter per second towards up, 16 meter per second in the horizontal direction. See, boy is also running 16 meter per second in x axis and then 16 meter per second the bird is also coming in the x axis. Then the velocity, see, the second part of the question, first question, first part, second part. So second part is velocity of the bird, I will write in small, bird with respect to boy, which is equals to velocity of a bird minus velocity of a boy is equals to velocity of a bird with in x axis 0, velocity of a boy, sorry, this is 16, right? 16 minus 16, which is equals to 0. This in the x-axis, guys. What about the y-axis? Boy is not going in upward direction, no? Yes or no? He is seeing like this. He is seeing like this, observing like this. That's it. So 0 meter per second. They are going same. Like third thing, old man, no? Velocity of old man with respect to boy, which is nothing but VO minus VB. Right? If you notice here, old man is coming in opposite direction of the boy. Everything you should assume that this is plus, he is also coming in positive direction, but the old man is coming in negative direction. Keep in mind, whenever you are doing, draw graph, plus, plus, minus, minus. So he is coming in the opposite direction. So that is negative. So minus 2 meter per second, that is minus 2 minus of 16, right? So answer is minus 18 meter per second. So this is the answer for the first question. Okay, answer for the first questions. This is 0, sorry, not 0, it's 18, right? 18 I cap. Okay. Now, can you give the answer for the second question similarly? Find the velocity of a tree, bird, boy as seen by the old man. First thing we have seen, tree, bird, old man as seen by the boy. So, what is the thing? Velocity of a tree with respect to boy. Next, velocity of a bird with respect to boy. Bird, boy, okay. Next one is velocity of a old man with respect to boy. Velocity of a old man with respect to boy. Okay, this is the thing we found. Second question. Question number 2, part 1. Velocity of a, right, velocity of tree with respect to old man, no, old man is equals to velocity of a tree minus velocity of a old man. Write the formula, that's it. Now, if you see, velocity of a tree is 0, it's a constant, right, it's like it's at the rest. Okay, next, velocity of a old man coming in the opposite direction, that is in the negative direction, minus 2. Okay, velocity of a tree 0 minus of 2, no, minus of minus 2. Okay, so 2 meter per second, 2 meter per second. See, simple thing, like a person coming in a vehicle with some speed. Okay, some speed. What you will say, if he is coming, you will assume he is coming in the negative direction or negative speed. No, right, he is coming with the positive speed. That's what the concept for the tree as well as the old person. So next thing, the second part, velocity of a bird. I'll write velocity of a bird as seen by the old man with respect to old man, which is nothing but velocity of a bird minus velocity of the old man, right? Old man. Am I correct? Okay. Is equals to velocity of a bird 16 minus velocity of a old man. So it's coming in the opposite direction, minus 2. So it is 18. 18, right? Yeah, fine. Similarly, third one, velocity of a bird, sorry, velocity of a boy as velocity of a boy by old man, which is nothing but velocity of a boy minus velocity of a old man. Am I correct? Yes. So which is velocity of a boy is 16 minus of minus 2, which is equals to 18, Okay, this is the answer for the second part of the question. But the third part, no, little bit confused. Yes or no? See, if I see the bird, no, bird is going upward on this like x axis as well as y axis. I need to take both. But if I see these things, no, like a boy, old person or a tree, everything in x, in x axis only, but the bird is in y axis also. I need to calculate that also, right? See, simple thing, keep in mind. Now, velocity of a tree with respect to bird, right? Velocity of a tree with respect to bird, which is equals to velocity of a tree minus velocity of a bird. Velocity of a bird. So if you see velocity of a bird, no, in this case, one is positive x-axis, one is positive y-axis. So noted that if it's going positive, no, with respect to the tree, it is minus 16 I cap minus 12 j cap. That's it. This is the answer. This is the answer. Similarly, we will do for the velocity of a boy with respect to bird. See, velocity of a bird with respect to boy, it is different case, as boy is saying, but as a bird is saying, no, velocity is in both direction. I should take the both direction also, both the direction. See, the with respect to is important. The word with respect to is there, no, it's most important in the relative velocity, acceleration, or whatever it is. Okay, that's the most important thing. So that's why the answer was different here, like boy, bird, the answer was different, but here boy and bird answer will be different. Velocity of a boy with respect to bird, which is equals to, okay, which is equals to velocity of a bird, so boy minus velocity of a bird, right? Boy is 16 plus 16 minus, now if you see, one is going in the x-axis, no, like keep it simple, this I cap. Now 16 I cap, one is going in the positive y-axis, that is plus 12 j cap. Now it's clear, no, now it's clear. The same thing I will write it here so that you can understand. So it is 0 minus, no, minus, both are in the positive axis, no, x-axis, positive y-axis. So plus 16 I cap plus 12 j cap. So you can get it like minus 16 I cap minus 12 j cap, the same thing I have written. So now we can understand easily. So 0, but I have taken in the both x-axis and y-axis. So similarly we will do for this also, okay. So this one 16 I cap minus 16 I cap plus minus 12 j cap. So 16 cancel, 1 with 12 minus 12 j cap. Now about old man, velocity of a old man with respect to bird, which is nothing but velocity of old man minus velocity of a bird. So velocity of old man coming in negative direction, right? Minus 2 I cap minus, now totally positive this thing, 16 I cap plus 12 j cap. Am I correct? Yes. So what I will get, minus 2 I cap minus 16 I cap minus 12 j cap. So if I add minus 2 minus 16, I will get minus 18 I cap minus 12 j cap. This is the answer, guys. Hope it's clear, guys, the given question, right? So whenever we are doing the question, with respect to is the most important thing in the question, okay. With respect to the word is the most important thing. According to the word only, like according to the reference, we'll write the equations, okay. So keep in mind, if this is like take the graph, mark it plus x axis minus x axis plus y axis minus y axis, then do the problems and mark this also in I cap j cap also, okay, I cap and j cap, then it will be easy for you to understand. Next is river and boat problem in 2 dimension. See, river and boat problem in the sense like suppose there is, let me go into the slides first. So in introduction to the river boat problem involves relative motion in 2 dimensions, important in motion in a plane when velocity is not aligned with the river. Yes, the thing is water is flowing in this direction, okay, in horizontal direction, but you need to go in the vertical direction, right? Water is flowing, you need to go from point A to point B. Simple thing, this is the path where water flows like this. You need to travel from point A to point B like this. What you will like, you will travel exactly like this in the same direction. Yes or no? You will travel? No, right? as the water coming like this, your boat also will move with the water, like totally it will not move, but some part, like it will be tilted like this and it will go like this. You will reach some point C. Am I correct? Yes or no? So as a river flowing, you are going like this. Suppose a river is not flowing, like river, water is at rest only, will keep. You want to move, you can move easily from point A to point B, right? But river is also moving and you also moving. Then two motions are taking place simultaneously. No? Simultaneously. So that's why we are dealing with river and boat problem. So depends on boat speed and river current speed. River current speed in the sense, so how much speed the river is going. Okay. So the key variables have been given. Velocity of a boat, like velocity VB is nothing but velocity of a boat in still water. One more thing, like we can write velocity of a boat with respect to ground also. I can write like this now, velocity of a boat minus velocity of a ground. What is the velocity of a ground? Ground is at rest only. So 0, right? Velocity of a ground is 0. I can write only VB. So I can either write VB or else VBG. Okay? Keep in mind, in question, sir, the question is asked VBG, velocity of boat with respect, like boat with respect to ground. Then what I should take? No need to worry, velocity of a ground is 0. Okay? So both are equal only, guys. Next thing, velocity of a river is VR. This also can be written in terms of VRG, which is nothing but velocity of a river minus velocity of a ground. Velocity of a ground is 0. Okay. Next, theta is the angle of motion with river bank. So if I see here, no, there is some angle made here. That's what they have mentioned. Okay. So V net, effective velocity of vector. Okay. This one we will discuss it. Okay. Next thing. Yeah. So downstream or upstream. So what is downstream and what is upstream, sir? See, down the stream is nothing but there is a river flowing area. Okay, like this. I'll take this as A. Similarly, B is there. Similarly, B is there. Suppose a person, this is the direction of the river, guys. Direction of the river. Okay, person is standing and you want to swim in the number A river. Okay, in the direction of the river only. What you will do? Like he is applying some speed to swim, but with the flow of the river, he'll like his speed also increases, right? So he will go with the flow of the river. That is down the stream. We'll say you are going along with the water is nothing but down the stream. Up the stream is nothing but, see, the same person is standing in opposite side of the river and he want to swim. So he is coming, like he want to go in the opposite direction of the river flowing. That's the upstream, will say. So now you understand now downstream and upstream. So going in the direction of the river is nothing but downstream, and going like opposite direction of the river is nothing but upstream. Okay. Now if you see here, if I want to find the velocities, see, velocity of river with respect to the buoy, okay, the buoy, or velocity of the buoy, both also we can find. River with respect to buoy, velocity of a buoy with respect to river, both also we can find. See, what is the formula we know? Simply V, first variable R, second B, as it is. For the first case, guys, I am writing for the first case, case A, case A. Okay, for the case A only, buoy with respect to river, velocity of a buoy minus velocity of the river. Am I correct? No? This is the thing. Both are in the positive x direction. Positive x direction, this is also positive, this is also positive. Now if you see this one, no, buoy is coming in the negative x direction, river is going in the positive x direction. Now case 2, this case B, velocity of the river with respect to buoy. So velocity of a river minus, okay, velocity of a river in positive direction, velocity of a buoy is negative direction, no. So minus of minus VB. So VR plus VB. Hope you got it, no? So velocity of a buoy with respect, like river with respect to buoy, VR minus of minus VB, because buoy is coming in opposite direction. right, is coming in the next negative x-axis. Same thing, velocity of a boy with respect to, like river with respect to boy, okay, boy with respect to river, which is nothing but VB. VB, boy is negative direction, no, minus VB minus VR. That's it guys, simple thing. Keep in mind, positive x-axis, negative x-axis, y-axis and negative y-axis. Then apply the formula. These two things if you keep in mind, you can do the problem easily in the relative motions. Okay. Next thing, crossing the river, like you need to cross the river. How much time it will take? If I want to cross the river, this is the shortest path, no, shortest path. If I draw like this, this is the 90 degree. What is this one? Pythag, like hypotenuse, no, hypotenuse is the longest side of the triangle, right? So this will be my longest distance. I want to travel in the shortest distance. One thing is shortest distance, another thing is shortest time. Okay, shortest time, both are there. We are going to discuss both of them. Okay, first thing, like crossing the river perpendicular, boat aims directly across the river, drift occurs due to the river flow. I want to go from A to B directly. Due to flow of the river, I am drifting from point B to point C. How much drift has been taken place? So how much distance has been taken, like from point B to point C? That's the thing we need to cover, right? The same thing, if the minimum time or shortest path, minimum time head directly across the, okay, directly across, maximum speed occurs with, shortest path head at an angle which cancel the drift. Listen guys, simple thing, if I want to go in a shortest path, I need to travel in this direction. If I want to go in a shortest time, keep an angle like this, you will go with along like same thing, A, B, this is the shortest path, you will take the shortest time, you are going along with the river, that's the thing. We will see in an equation, okay, we will see in an equation, point A, point B and this is point C. This is the velocity of a boat with respect to water. I am keeping like this, I am keeping the boat like this, but due to the water flow, no, it went like this, no. So velocity of a boat with respect to ground I have taken. Okay, in some books they have mentioned differently, like velocity of a boat with respect to ground. This one is velocity of a boat with respect to water. Okay, see both are same only. Okay, so when you are taking like this, angle also changes. If you change this thing, no, angle will be changed. You need to interchange the angle. That's the thing. No need to worry. Both are same only. Okay. Now crossing the river in shortest path, crossing the river in shortest time. These both we are going to calculate. First we will calculate the angles. Sin theta first. Sin theta equals to, sin theta is nothing but opposite by hypotenuse, no, opposite, velocity of a water with respect to ground divided by velocity of a boat with respect to water, cos theta, adjacent, velocity of a boat with respect to ground, velocity of a boat with respect to ground divided by velocity of a water, boat with respect to water, tan theta, which is nothing but velocity of water with respect to ground divided by velocity of boat with respect to ground. This is the thing. So in some books it will be interchanged, like velocity of a boat with respect to water, like that. Okay, it will be interchanged. That's the thing. No need to worry. Now shortest time we need to calculate. No, shortest time. So this is the shortest path. I will take the angles. This one will be my velocity of boat with respect to water, cos theta. This is my angle, velocity of a boat with respect to water, sin theta. The formula, speed is equals to distance by time. Time I need to calculate, time is equals to distance by speed. How much speed? Velocity of boat with respect to ground. that is velocity of a boat with respect to water cos theta. That's the thing. You keep in mind this one, only this diagram, velocity of a boat with respect to water, velocity of a boat with respect to ground, okay, BW, BG. This is as it is, velocity of water only in this direction, only you need to keep in mind this one. The same thing you are going to apply here, this thing in the inclined angle and this one in the straight direction, that's the thing. Excuse me. You couldn't hear the voice, guys. Hello? Kaiser? What happened? Lavanya Radhakrishnan. You can listen the class, ma. Am I audible? No? Yes, yes, okay. Okay, guys. So the same thing which we are going to apply for the rain and man problem also. The same concept only, guys. No need to worry. See, rain, velocity of a rain. This is velocity of a rain. Can I take a new page? Okay, I'll add it. VM and VRM or VMR. These are the things, like these are the variables which we are going to use in the velocity of a rain or velocity of a man with respect to both of them. I'll write it here, velocity of rain. This is velocity of man. This is velocity of rain with respect to man. Am I correct? Yeah. This is velocity of man with respect to rain. So how I will write this one? Velocity of a rain minus velocity of man. Okay, this one velocity of man minus velocity of a rain. So in previous case, the same concept only. Okay, yeah. So if a rain is coming like this, it with at what angle I need to keep the umbrella? Okay, or else if rain is coming like this, a person is walking like this. Sorry guys, I am weak in drawing. Okay, adjust it. So rain is coming like this, rain is coming like this, or else like this. I need to find the what angle I need to keep the umbrella so that I will not be wet. Okay. Okay guys. So we will continue with this with the next class. Okay. So next your botany ma'am will come. Take 5 to 10 minutes break. At exactly 6:30 class will start. Until then, bye bye guys. Bye bye bye. Indian Studios.